What's the area of the shaded blue section of this figure, which is clearly a circle with two squares inside? Watch as we use solve to figure this out. Solve is just a way of me to create a plan or using the information I have, and it gives me a lot of structure for this. I learned this from another great school I worked with last year. So we'll start with, well, what does solve stand for? In S, we're going to state what the problem is asking in our own words. We're going to organize our facts. We're going to line up our plan in words. And then on the next page, we're going to verify our plan, put it into action, and then explain. So let's go back to S. And pretty much what are they asking us? What's the area of the circle minus the area of the squares? Clearly, that's what they're asking us because these two squares are inside the circle. I need to take them away from the area of a square. So first things first is organize some facts. What do we know? We do know the area formula for a circle. I write both of them down. My circle formula is cherry pie delicious, or circumference is equal to pi times diameter. And apple pies are 2 is how I remember the area formula for a circle. And clearly for this to work, I'm going to need a radius, which we do not have yet. But we do know that the two squares on the inside, their area is just as the side squared, and we know each side is equal to 4 because each side has 2 plus 2, so it's equal to 4. Okay, what else do we know? We know that 2 points of the square are on the circle itself. That's going to be super important because it means that I can do something about that. If 2 points are already on the circle, I'm going to watching my plan, I'm going to use those 2 points to figure out the radius or diameter of this circle. I'm going to extend the lines of those squares to create an inscribed rectangle. All right, so I'm just going to extend them. I'm going to just make them longer until they touch the edges of that circle, and we're going to have a rectangle inside of this circle. And that's perfect because once I have a rectangle, I can find the hypotenuse. Just go across, make a diagonal from one point to the other, and that's the hypotenuse of a triangle inside the rectangle, and that's going to help me find the diameter. And once I have the diameter, this is easy. Then I'll be able to find the area of a circle, because if I have diameter, I can find radius, and then I can just subtract the area of the two squares, which I have enough information for. So hit pause in case you want to look through this entire plan one more time. And again, I'm using these 2 points here, and my plan is to extend these points so that they have an inscribed rectangle. Once I have that, I can very easily figure out the diameter of this circle. All right, we're going to verify this plan. We're going to play it out. So again, let's just connect those points. We're going to predict, I'm going to extend this line. So somewhere around here will be that point, and somewhere around there will be the other point. All right, so I'm going to draw out those lines. Here we go. And there you have it. Here's our inscribed rectangle. And I'm going to create a diameter right here. So what do we see? What do we notice? So here's my rectangle. And inside my rectangle, I have 2 right triangles. So I can use my Pythagorean theorem to find this distance. What else do I see? So we can see that each side of our squares is 4. So that means this is 4, and that means this is also 4, which means this whole side of our triangle is 8. And on the other end, this part here is 4, and this part here is 2, because I can see it. So that means this entire side is 6. So having that, we can just apply the Pythagorean theorem. A squared plus B squared equals C squared. So 36 plus 64 is equal to 100. That's a nice, easy square number. C is equal to 10. Our diameter is 10, which means our radius is equal to 5. Now I can plug that in. Remember, apple pies are 2. So that would give us r squared. 5 times 5 is 25. The area is equal to 25 pi. And if you were to go and put this into your calculator, I think you would get, well, let's find out. Let's put our calculator here on the page. Okay, 25 pi using my calculator is just 78, and I'm going to round this to 54 hundredths. So the area of the circle is equal to 78 and 54 hundredths. Now we just have to find the area of our two squares, which is pretty easy because each square has a side of 4. So the area of the rectangle is equal to s squared, or just 4 squared, which is just 16. And because I have 2 of them, 16 times 2 is equal to 32. All right, so final step. Area of the circle, I'm just going to do 78.54 minus 32, and we get our answer 76.54 square units. There we go. That is the area of the blue part. So again, let me just explain all we've done. We wanted to find the area of this blue shaded part. We had 2 squares inside the circle. So all we did was extend the squares so that we would create an inscribed rectangle inside the circle. Once we had our rectangle, we can use the Pythagorean theorem to find the diagonal of the circle. It was the same as the hypotenuse of one of the right triangles. Once we have this little part right here, it's really easy to just figure out the area of a circle. We know the radius has to be 5 in this case, and we just use that information to plug it into our formula. Once we have our answer here, we took the area of the 2 squares, subtracted it to find the area of just the shaded part. And that's it for today, Math Marbles. I love these kind of puzzles. Geometry is a lot of fun. It's not just shapes, it's shapes and logic and algebra put together. There's no way. How do we separate our love from algebra from geometry? Well, I hope you enjoyed it. Let's see if I can solve more puzzles this year. And if you want to have more problems like this, add them in, put them in the DMs, put them in the chat. I love to see these, and I would love to see your strategies for solving them as well. That's it for today, Math Marbles. Be well.